Welcome back, dear students and parents. I am chemistry lecturer SRIKANTH SUNIL from the VISHRA Academy situated at Balapur X Roads. Now I am going to discuss 31st Jan evening session JEE mains paper. We are going to discuss chemistry, and chemistry first we will discuss the multiple choice questions, then we will go to the numerical value type of questions. So first let us start with the multiple choice questions. So see here students, first one. Right, first one. There are two statements, statement number 1 and statement number 2. First statement they are saying that S8, generally this S8 will be converting into Na2S and it will be converted into Na2S2O3. Na2S2O3 generally known as hypo. So this is the first statement. Second statement is ClO4 minus undergoes disproportionation. ClO4 minus undergoes disproportionation. Undergoes disproportionation. So whether both the statements are correct or not, or both are incorrect, or one is correct, one is incorrect, we'll let us see. See, observe this statement, students. Observe this statement. Okay, the statement is first one. You can take S8. You can take S8. S8 when it reacts with NaOH, obviously this one will give S-2 ion and it will certainly give S2O3-2 ion. Okay, so it is correct and this is oxidation and let us see ClO4 minus. In ClO4 minus, chlorine is in +7 oxidation state. Here it is in 0 oxidation state, this one is -2 and this one will be converted into a higher oxidation state, or we can say +2, -2 +2. So this one is undergoing disproportionation, but this one it cannot undergo no disproportionation. So now let us say why this ClO4 minus perchlorate ion cannot undergo disproportionation. So for disproportionation it should increase its oxidation state and it should also decrease its oxidation state. Decrease of oxidation state is possible. Okay, we can say that decrease of oxidation state is possible. So it can act as an oxidizing agent, but when it has to act as a reducing agent, it has to increase its oxidation state, which is not possible. Chlorine maximum oxidation state +7 is maximum. So it cannot increase its oxidation state. When it cannot increase its oxidation state, then it cannot act in a disproportionation reaction, because oxidation is possible, oxidizing agent is possible, but reducing agent is not possible. So this statement is correct, this statement is wrong. So first statement is correct, second statement is incorrect is the answer that you have to select. So now let us continue with the second question. Second question is there are some options here and you have to select which option is correct. So in this there are two compounds that are mainly given. So let us see the compound NiCl4 and this one is 2- ion, and we can say NiCO taken 4 times, NiCO taken 4 times. These two are nickel compounds, and this one is a carbonyl compound. So these two we are talking, which one is paramagnetic, which one is diamagnetic. This one is diamagnetic in nature, this one is paramagnetic in nature. One is diamagnetic, other one is paramagnetic. In fact, I have to write like this: nickel is diamagnetic in nature. So let us imagine this. So this one is paramagnetic in nature. Paramagnetic in nature, this one is dia. So let us see why this is paramagnetic, why it is diamagnetic. So we will go to NiCO taken 4 times. In this, its nickel is in +2 configuration. This one will have 4s2 3d8 configuration, 3d8. 4s2 3d8 configuration, and whenever chlorine is there, there is no pairing up. Whenever cobalt is there, there is pairing up. So in this, Cl minus, no pairing, and CO pairing is there. So that's why this one is dia, this one is paramagnetic in nature. So carefully we have to understand this concept. So students, let us move to the third question. Third question is also similar. 2 statements are given and we have to write the statement 1 and statement 2. Analyze statement 1 and 2 whether both are correct or one is correct, one is wrong, or both are wrong. That's the question here. So let us see. First one. In the 15th group, hydrides reducing character. Hydrides reducing character decreases. Hydrides reducing character decreases from NH3 ammonia to bismuthine. Ammonia to bismuthine. So let us see the next one. Statement number 2. E2O3. E2O3 is E is one of the compound of 15th group, and E2O5. E2O5. These two are not always basic. Are not. See here. Are always basic. Are always basic. Are always basic. These are the statements that we are getting. So we can say this one is also wrong, this one is wrong. Both statements are wrong. How you can say both statements are wrong? E2O3 and E2O5. E is 5th A group element. They are not always basic in nature. Some are acidic in nature also. So that statement is correct. And the hydrides reducing character decreases from NH3 to we have BiH3. That is also not reducing character decreases from NH. This is also not correct. So both statement 1 and 2 both are false. Simple statements based on the 5th A group elements. So this one is question number 3, students. I think all of you understood the concept. So let us go to question number 4. Question number 4. So fourth question, let us see. Very interesting. It is based on the Fazan's rules and they gave 4 options. First one is KCl, second one is AgCl, silver chloride, and third one is our cobalt chloride, and fourth one is BaCl. See, cobalt and silver both are having pseudo inert gas configuration, we can say. So they are not good ionic character containing compounds, they are more covalent natured compounds. BaCl2 and KCl2, Ba belongs to a higher charge or to a group, K belongs to K plus. So more ionic character. According to Fazan's rules will be KCl, because KCl big cation, KCl K plus is a big cation, Cl minus is a small anion. When cation is big, anion is small, generally the polarization will be less and they will be more and more ionic in nature. So more ionic character will be there for KCl. This is how we can explain the fourth question based on the Fazan's rules, dear student. Chemical bonding question, basic question. Now let us go to question number 5. Question number 5. So let us see the question number 5. We have to compare, match the following. CrH2O taken 6 times, chromium hexa aqua compound with +3, and there is another compound iron with H2O taken 6 times, and this one is also having a +3 charge on it. This one is nickel with H2O 6 times. All are octahedral complexes, so no need to worry about their geometry. All are having same geometry, and we have to say which one will have in crystal field splitting. In crystal field splitting, which one is having correct configuration, we have to match. So this is 1, this one is 2, this one is 3, this one is 4. So let us write A and B and C and D. Let us try to compare this. T2G taken 2 times, T2G 2, and EG will be having, small eg will be having 0. T2G3 and EG will be having 0, and T2G3 and EG will be having 2 configuration, and T2G6 and EG will be having 2 configuration. All of you know that we can write the crystal field splitting like this. T2G here and EG here. EG will have 2 here, 2G will have 3. So the filling will be done here, then it will go there. Depends upon the ion and how the configuration is there. So let us see. First one is bonded to 2. These 2 are matched. Second one is bonded to 3. Second one is bonded to 3. And third one is bonded to 4. Third one is bonded to 4. And fourth one is bonded to the first one. This one is the match the following of this 1, 2, 3 and 4 and A, B, C, D. Like that we can write the electronic configuration or crystal field splitting like this. So I think all of you understood this. Based on the crystal field splitting, the complex compounds, these are explained like this. This one is the 5th question, dear students. Let us go to the 6th one. Question number 6. All of you concentrate here. 6th one. Question number 6. So now you will get more easier questions, dear students. Now, K atom. What is K atom? Potassium. Outermost electron. Outermost electron of K atom. What will be its quantum numbers? What will be its quantum numbers? Quantum numbers, what are they? So let us write K atom 1s2, 2s2, 2p6, 3s2, 1s2, 2s2, 2p6, 3s2, 3p, 6, 4s1, this one is the last electron, 4s1 is the last electron. So n principal quantum number will be 4, then L will be 0 azimuthal quantum number. So m is also equal to 0. S can be plus half or it can be minus half. So select these quantum numbers and select the option which is having the proper n, L, m and s value. S value, it can be in clockwise or anti-clockwise, the plus half and minus half, anything you can take, but both options will not be given. If both options are given, check the option like A and B both are correct or A and C both are correct, that options are there or not. So like that we can explain this configuration. Generally they gave plus half, so you can write plus half, 4, 0, 0 plus half. This one is the 6th one. Let us go to the 7th one, dear students. 7th question. 7th question based on Markovnikov addition. Don't worry about these structures. They look very big and complicated. But you are adding DCl. What is this DCl? All of you know HCl. Heavy hydrochloride is a DCl. Heavy hydrochloride, you are using deuterium here. Instead of hydrogen, you are using deuterium. So what you are going to get? Simply, you are going to get Markovnikov addition. So D will be attached here where more number of hydrogens are there, and C will be attached, Cl will be attached there. So this one will be the option. This one is the option. So this one is Markovnikov addition. So here where more number of, here no hydrogens, here one hydrogen is there. Where more number of hydrogens are there, there the hydrogen will go, and here hydrogen is heavy hydrogen, so that's why it went to this. And this one is the correct option that you have to select based on Markovnikov rules. Very easy question from organic chemistry. But it looks complicated but not so complicated. So let us go to the question number 8. Question number 8, they gave two compounds. There is a benzene compound. This one reacts with a benzoyl chloride compound. Benzoyl chloride compound in the presence of anhydrous AlCl3. Anhydrous AlCl3 is a Lewis acid, and generally it is used in Friedel-Crafts alkylation acylation reactions. Here also in the same way we can use the alkylation acylation. Phenyl benzoate can be the answer. Phenyl benzoate can be the answer. This one is phenyl benzoate. This one is the correct answer. Phenyl benzoate can be taken here because these two combine. Here H, here we can say H is there, and this H will be reacting with this and this one will be removed, and there you will get the phenyl group, phenyl benzoic benzaldehyde, benzenone, phenyl benzenone we can say. This one is question. Students, now we will go to the 9th question. Let me write the 9th question. It is based on the Gutterman-Koch reaction. So they gave a direct equation like this. There is a benzene compound. To this benzene compound, carbon monoxide plus HCl is added in the presence of anhydrous AlCl3. So what they are saying is it is giving benzaldehyde. This is a preparation of aromatic aldehydes, benzaldehyde. So now we have to name the reaction. They gave different names. Rosenman reduction? No, not it is. Stephens reduction? No. Gutterman-Koch reaction? Yes. Itard reaction? Yes. This is Gutterman-Koch reaction. So you have to select the named reaction, name of the named reaction, which is based on this type of equation. So it's very basic one. Already I told you, organic chemistry, you have to study all the named reactions, brush up all the points, and you have to go before going to the examination, so that you can remember the equation. Direct questions are asked on the named reaction, so compulsory we are getting at least one question on that. Students, we will go to the question number 10. Question number 10, there are some statements in these statements which are correct statements we have to tell. First one, A statement, MN2O7 is oil at room temperature. Second one, V2O4 reacts with acid, means plus acid, it's going to give you VO3 plus ion. C. CRO is a basic oxide. CRO is a basic oxide. It's a very lower oxide, so it can be treated as a basic oxide. And then comes D. In this D, they gave V2O5 does not react with acids. V2O5 does not react. With acids. V2O5 does not react with acids. Students, these options let us observe. Mn2O7 is a oil, thick oil at room temperature. Okay, this one is correct. V2O4, if you add to an acid, VO3 plus will come. This one is also correct. CRO is a lower oxide, so it will act as a basic oxide. Higher oxides generally act as acidic oxides. And this one is does not react with acid, they said. So this statement is wrong. It will react with acid as well as base. So that's why A, comma, B and C are correct statements. So choose the options where A, B and C, all the three are correct. This one is the solution for the 10th one. Students, let us go to the 11th question. 11th question is also based on organic chemistry. So let us go to the 11th one. 11th question is very simple. You take bromobenzene. You take bromobenzene. To this bromobenzene, add a nitration mixture. What is nitration? Concentrated HNO3 and concentrated H2SO4 combination is known as nitration mixture. Then a compound A will come. This one is A. Then A, to A, add NaOH at a lower temperature in the presence of HCl. NaOH in the presence of HCl. Then gives B. What is A and B is what is the question. A and B, what is it is the question. So let us see bromine and how the compounds can be explained. So all of you take here, this one is the reaction when bromine is added to nitration mixture. This one is known as a nitration. On nitration you will get benzene with bromobenzene with NO2 in the para position. NO2 in the para position. So this one is A compound. A compound is NO2 in the para position. Then you have NaOH, a base in the presence of 573 Kelvin, and dilute HCl, dil HCl will be there. So dilute HCl, this one will convert Br into OH. So you will get the compound like this, phenol with NO2, para-nitrophenol. Para-nitrophenol is the compound. So this one is compound number B. So you have to select the option where A and B 4 combination is there. See the options and select A and B correctly. Yeah, students, I think all the questions are very easy for you to solve. Just you revise all this. Let us go to the 12th one also. 12th question we are explaining now. All of you see here, question number 12. In this 12th question, there are 4 compounds given. Benzene, you have chlorobenzene, you have toluene, you have nitrobenzene. Benzene, chlorobenzene, nitrobenzene and toluene. So, now see here, this one has no effect. This one less deactivating effect. So, the reactivity will be slightly decreased because of chlorine, but it will be less. And here ring activating group, very good in reacting, ring activative. So, now this one is ring highly deactivating. Ring highly deactivating. So, we can say like this, these are the compounds. Now, tell me what is the option here? Reactivity order of the following compounds. We have to see the reactivity order of the following compounds. So, we can say toluene highly reactive, then comes benzene, which is not having any effect at all, then we have chlorobenzene, which is slightly less reactive, but nitrobenzene very highly deactivating group. So, this one is the reactivity order of these compounds. Like that, we can explain the reactivity based on the activating and deactivating nature. Dear student, I think all of you understand. Question number 13. Almost we are done, students. Let us write the structure of this compound. What is the compound? 2,2 dibromo, 2,2 dibromo, 1 phenyl, 1 phenyl pentane. This one is the IUPAC name. You have to write the structure. Pentane is the main. 1, 2, 3, 4, 5 carbons. On one you have phenyl group PH. The phenyl group is here. On 2 you have bromo. Here you have bromo and here you have bromo. Write the hydrogens here, dear students. You are done with the question. This one is the structure of this IUPAC name. So, see here, this one is CH2 attached to this and phenyl. So, like that we can explain the structure name. Yes, students, let us move on to the 14th question. We are explaining the 31st of January evening session question paper of chemistry. 14. Statement is like this: aniline on reaction with concentrated H2SO4. What is aniline? This one is aniline, NH2. This one on reaction with concentrated H2SO4. Aniline on reaction with concentrated H2SO4 at 475 Kelvin temperature gives para-amino benzene sulfonic acid. Para-amino benzene sulfonic acid. I'll write the structure afterwards. They gave the name here, so you should be able to understand the structure and write. So, that is statement number 1. This one is statement number 1. Let us see what is statement number 2. Statement number: aniline forms a salt with anhydrous AlCl3. Aniline, based on aniline the question is given. Aniline forms a salt with anhydrous AlCl3 in Friedel-Crafts reaction. This is statement number 1 and statement number 2. Now, what they are asking, which of the statement is correct, which of the statement is wrong. So, option is both statement 1 and 2, both are correct. What is the answer? Both 1 and 2 are correct. How both 1 and 2 are correct? Let us see the compound and how it will react. See here, this one is benzene with NH2, this one is aniline. Aniline can convert into this compound and this one will give actually this gives a zwitter ion and slowly the zwitter ion turns into para amino benzene sulfuric acid. I wrote here na para amino benzene sulfuric acid is this one. Now let us see the compound. Yes, it gives a salt with anhydrous AlCl3. This one is NH2 plus AlCl3. It's going to give you a salt here, and this one is what we can write. This one is NH2 with a plus sign, and here we have minus sign. This one is the salt. So option 1 as well as option 2 both are correct. All of you observe the answer. Students, we are going to now answer the 15th question. 15th question is also an organic chemistry question. So 15th question. Let us see the 15th question. 15th question, there are two compounds given. This one is nitrogen with CH3 and CH3. So this one is aniline with N, N dimethyl. And then you have benzene diazonium chloride here. Here you have N2Cl and here you have SO3 minus and Na plus. These two are combining. What will be the product? What will be the product? This is what they are asking. What will be the product? So now let us see what will be the product. So the compound here we are going to get is, this one is the product. Coupling reaction, azo di reaction, and then you have benzene ring here with SO3Na. This one is the compound that we are going to get. This one is a coupling reaction. This one is nothing but methyl orange. Methyl orange reaction is like this. So like this we can explain the question number 15. Question number 15. Question number 16. Question number 16. Okay, let us see what is this question. This one is based on the Kp values, equilibrium constant. So there is A with G and this is in equilibrium with B, which is also a gas, and it is half C, which is also a gas. This one is the equation. Now what is the relation between Kp, alpha and P relation? Relation they are asking. Kp, alpha and P. Kp, alpha and P. So now let us see this equation. A is in gaseous state. This one is having B, which is also in gaseous state, and half of C is there, which is also in gaseous state. All are in gaseous state. So we can say initially, if you take n moles, this one is 0, 0, initial. Finally, at equilibrium, n into 1 minus alpha will be the dissociation constant, then n alpha, degree of dissociation, n alpha divided by 2 if you multiply with n. So using this, you are going to get the Kp value. Kp value is equal to alpha to the power of 3 by 2 into P to the power of 1 by 2 divided by 2 plus alpha whole to the power of 1 by 2 whole to the power of 1 by 2 and 1 minus alpha. This one is the expression that you are going to get. So this expression you have to select from the options. So alpha is degree of dissociation. Degree of dissociation. N is total number of moles. And here alpha is degree of dissociation. Relation between Kp, pressure, total pressure, and also the alpha. So total pressure, we can do it like this. This one is the answer, students. Now, the multiple choice questions are over. We have another four questions which we are not able to deliver at this point of time, and we would like to deliver in the near future. We are not able to guess the questions. Once the key comes, we can take our all the other 4 questions and we can explain that. We will move on to the numerical value questions, students. Yes, students, we are into numerical value based questions. This is from question number 21. So let us see the question number 21. Question number 21. So what is question number 20? Half-life of first order reaction. T half of a first order reaction is 36 hours. T half of a first order reaction is 36 hours. And find out the time in hours required for concentration of reactant to get reduced by 90%. Reduced by 90% means 10% left. 10% left. So T half is 36 hours and find out the time in hours. So we will take T90. We have to do it according to the problem. Here this is not a multiple choice. 2.303 by K log of 100 by 100 minus 90, because 90 is over. So this one gives 2.303 by K by 2.303 by K into log 100 by 10, which is log 10, and this one is T90. So we can get T90 in this way. T90 is equal to, how to get the K value? T half. T half is equal to 0.693 divided by K. So K is equal to 0.693 divided by T half. T half means 36 hours. You can take this and substitute in K, and you will get the K here value as T of 90 is 120 hours. So 120 hours is the answer for the 21 numerical based question. Simple first order kinetics equation. Okay. Students, up to here we have to calculate the K value from the T half reaction of a first order reaction. Then substitute the K value here, and then you will get this value, and this T90 value will be nearly 120 hours. So we can say that numerical answer for this 21 question is 120. Yes. Question number 22. It is based on the work equation for isothermal and reversible. Isothermal and reversible. See here, minus 2.303 nRT, minus 2.30 nRT, log of volume of final by volume initial. This one is the equation that we require. This one is the equation that we require. But generally we take the work in the modulus, so it will be 2.303 nRT log V2 by V1, log V2 by V1. So in the question, from 1000 liters to 100 liters the expansion took place. 1000, it's an ideal gas, 1 mole of an ideal gas, and the expansion is from 10 liters to 100 liters. So we can write the expression like this. Modulus of W is equal to 2.303 into 1 mole of an ideal gas into 8.314 into temperature 300 Kelvin given in the problem, and then we can write log of 100 by 10, 100 by 10, which is log 10, which is equal to 1, and you multiply. Finally, you are going to get the value like this. Nearly, this one will give 5.744 joules. So nearly it is 6 joules. So 6 is our integer type of answer for the 22 question. 23rd question, all of you know that there are A, B, C, D, E, K vitamins. A, B, C, D, E, K vitamins. In this, which of them are stored in the body, means which of them are fat soluble. What are fat soluble? Fat soluble ones are A, D, E, K, and we can say vitamin B12 also is fat soluble. What is water soluble? Water soluble are all other B vitamins and C. Both are water soluble. So they asked, how many of the following vitamins are stored in human body? So 4 is our answer. A, D, E, K, these 4. So 4 is our answer. Number 24, very easy question. All of you see here. Number of moles of H plus required by 1 mole MnO4 minus. Number of moles of H plus required number of moles of H plus required by 1 mole MnO4 minus potassium, say potassium permanganate or permanganate ion to oxidize oxalate. What is oxalate? Oxalate is oxalate ion is C2O4 minus 2 is oxalate ion, 2 carbon dioxide. Oxalate will be reduced to carbon dioxide, and KMnO4 is the oxidizing agent. This one is the reducing agent. So reducing agent is oxidized to CO2. So let us see the reaction, how this one can be written. 2 MnO4 minus, balanced equation I am writing, plus 5 C2O4 minus 2 plus 16 H plus is going to give you number of moles of H plus required, we are saying. So this one is going to give you 2 Mn plus 2 ions, 2 plus ions plus 10 CO2 plus we can say 8 H2O. So how we can write? 2 moles required for KMnO4, 2 moles require 16, 1 mole requires 8 H plus ions. So we can say the option is 8. 8 is the numerical answer for this 24th question. Question number 25. Potassium chloride is heated with potassium dichromate. KCl is heated with K2Cr2O7 heated. And concentrated HCl is added, and then we are adding concentrated H2SO4, not HCl, concentrated sulfuric acid. To give the products, the oxidation state of chromium is, oxidation state of chromium is, oxidation state of Cr is, actually this one is plus 6, this one is the answer. How? Let us see the equation. K2Cr2O7 plus 4 KCl, balanced equation I am writing, KCl plus 6 H2SO4, 6 H2SO4 gives 6 KHSO4 plus 2 CrO2, Cl to chromyl chloride, and 3H2O. So chromium oxidation state here this one is plus 6, the highest that chromium can exhibit, because it's the 6th D group element. So plus 6 is the answer for this question number 25. Question number 26. So let us see the question number of structural isomer product found by monochlorination of 2-methyl-butane. What is 2-methyl-butane? 1, 2, 3, 4, and this one is like this. So you have CH3 here, you have CH3 here, here CH2, here CH3, and here H is there. So you are doing monochlorination. To this you are adding chlorine. Then what are the compounds that are formed? We are going to get 4 structural isomers. Four structural isomers. Let us see the 4 structural isomers. Of course, chlorination is a free radical reaction. Free radical mechanism reaction. So let us see the 4 compounds that are required here. So CH3 attached to CH2 attached to CH, and here CH3 is there, and here CH2Cl. This type of compound is formed. CH3 attached to CH2 attached to carbon, which is attached to chlorine, and CH3 and CH3. This type of compound is also obtained. CH2 attached to CH, here Cl is there, and you can attach this to CH, and this one is attached to CH3 and CH3. This type of compound is also obtained, and CH2Cl here, and here you have CH2 attached to CH attached to CH3 attached to CH3. These are the 4 isomeric compounds. So see here, this one, I will just change the color for this. This one, yes, this one is most important. This carbon is also most important. This carbon is also most important. This carbon is also most important, either this one or this one. So both are same. So you'll get 4. 4 is the answer. So students, all the other 4 questions we are not able to collect at this point of time, but we'll come back to you with all the memories based paper this is. So we are able to do well, I think. 4 questions we have to explain that we could not collect from our students. We are very sorry for that, and we will come back with the 4 questions in a short span of time. Bye dear students, have a good day.